identities. That is how we will be concluding the session today. Let me also talk briefly about our approach in the Janaganit program. Janaganit is brought to you by the Everybody Can Do Math Collective. Everybody can do math. Everybody. That includes everybody who is participating in this program. But mathematics cannot be learned by listening to a lecture. Everybody. Mathematics cannot be learned by who is watching a video. For doing mathematics, for understanding mathematics, for mastering mathematics, one has to do mathematics. And that is what we have been doing in the sessions from 1 to 8. And that is what we will be doing in the sessions going forward. Doing mathematics means solving problems. And you cannot master mathematics if you do not solve problems. And that is the essence of what we are doing here in Janaganit. You are not here to listen to a lecture. I am not giving a lecture. What we are doing here is giving you problems in a definite sequence. And to understand mathematics, you have to solve the problem that is given to you one by one. In every session, we are posing 20, 25, 30 problems. And you solving the problems one by one is the way in which you will develop your understanding of mathematics. We call it the GPS way to mathematics, finding your way in mathematics with GPS. Now, you know what GPS is usually means. It means a global positioning system. But here, GPS means graded problem solving. And by doing the graded problem solving, you will find your way in mathematics. So now let us begin by doing a few problems from last time, which will also prepare the basis for going ahead today. Remember, in session 7, we introduced 2 different languages for doing algebra. One was the T language, where T meant 10, and the other was the language of lines and rectangles. The rectangles represented a multiplication in algebra because the area of a rectangle is length into breadth. So if x is the length and y is the breadth, x multiplied by y is the rectangle whose area is xy. This is what we did in the last session. Let us begin by doing a few problems, which I will give to the participants who are here with us in the studio. I again welcome Nandita, and I welcome Jyoti, who have been with us in the past few sessions. Remember, T means 10. So the first question, I'll give you a few questions one by one, and you have to write those in your paper and tell me what it is. Say that in the mic. What is 2 times t? Jyoti, what is 2 times t?
2t.
2t. If t is 10, what is 2 times t?
20. 10. 10.
T is 10. So 2 times t?
20.
20. That is t plus t, or 20, right? That's just revision, so that those of you who are coming here for the first time also can understand the language. Next question is to Nandita. What is 3t?
30.
3t is
30.
30, right? This is what we have. 3t is 30. Okay, next question is to Jyoti. Also use your calculator. Okay, remember t is equal to 10. So use your calculator. Please take your calculators in your hand. You don't need a calculator, but use a calculator. As we go ahead, you will require it. So Jyoti, if t is 10, what is t multiplied by t?
Hundred.
100, right? So t multiplied by t, we called it as t squared. T multiplied by t we called as t squared. So Jyoti, what is t squared?
100.
100, right. Next question is to Nandita. Nandita, what is t multiplied by t multiplied by t?
T cubed.
T cubed. And what is it?
1000.
1000. Okay. So on your calculator, please multiply t multiplied by t multiplied by t. What did you get?
1000.
1000. And what did you take t when you were multiplying? You took t as
10.
As 10. Right. All right. Now, the next question is the following, which I'm going to write here and show everybody. This is the question. You have to tell me what is 2 into t squared. Jyoti?
200.
200. Very good. Right? And Nandita, what is 2 multiplied by 2t squared?
400.
400. Why?
Because 2 into 2 is 4 and t square is 100. 4 into 100 is
Because 2
400.
into 2 is 4 and t squared is 100. Earlier, Jyoti said that 2t squared was 200. So 2 into 200 is 400. Okay, that is why 2 into 2t squared is 400. The next problem is a little different. And I'm going to write it here. Everybody can see it. The next problem is, what is 2t multiplied by 2t. What is 2t? Gyanjyoti? What is 2t?
100.
2t.
20.
20. So 2t multiplied by 2t is what multiplied by what?
20 multiplied by 20.
20 multiplied by 20. Put that on your calculator. What do you get?
400.
400. Say that in, say 400 in T language. 100 is
400. T square.
T squared. So 400 is
4t square.
4t squared, right? So we see that 2t multiplied by 2t is 4t squared. All right, the next question is to Nandita. Nandita, what is 2t multiplied by 3t? Gyanjyoti, you can also do this on the calculator and see if, what is 2t multiplied by 3t?
2t is 20 and 3t is 30. So 2t into 3t is 600.
It is
600.
600, right. So do you know where the 6 comes from?
2 into 3.
Yeah, this 2 into 3 is 6, and this t into this t is t squared, which is 100. So 2t into 3t is 600, 6t squared. I can write this as, I can make 2 into t into 3 into t. 2 multiplied by t multiplied by 3 multiplied by t. So this 2 and 3 multiplied gives me 6, and t multiplied gives me t squared, which is 100. So it is 600. Good. We are just using our knowledge of multiplying 10 by 10. And as you know, that multiplying by 10 is very easy. It is the easiest part of multiplication. Multiplying by 10 is very easy. So we are using the property that multiplying by 10 is very easy, but we are replacing 10 by t, and we are learning the laws of multiplying algebraic quantities. So t is both easy in arithmetic, and t here also represents an abstract quantity. So we are using an easy part of arithmetic to understand some algebraic multiplication. And as you can see, algebraic multiplication is as easy as multiplying by 10. I will repeat it. Algebraic multiplication is as easy as multiplying by 10. In fact, it is even easier. Why it is easier, we will discuss later. So that is why we had said earlier that algebra is a very easy part of mathematics. So are we ready now to go further? The next question is, Gyanjyoti, you know what is 2t? So what is 2t plus 3? What is 2t plus 3?
23.
23, right? Very good. Nandita, tell me what is 3t plus 2?
32.
32. Very good. A slightly more difficult problem. Jyoti, tell me what is 2t plus 11?
31.
31. Very good. 2t plus 11 is 31. Good. And now, Nandita, the next question. What is 2t plus 3t?
5t.
5t. Right? Say that in numbers.
50.
50. All right. Are we ready to go to the next problem? Next problem is for Jyoti. I hope all the participants who are watching this on YouTube and on Facebook Live, you are also solving this problem in your books or in your mind. Please solve the problems yourself. And if you have not done it this time, then you can go back and watch the program again, a repeat viewing of the video on YouTube. And you can, those problems which you have not done this time around, if you miss them because you went a little bit too fast, that happens. But you can repeat those problems when you watch the video on YouTube again. You might need to watch it not once, but twice. I don't think you will need to watch it more than twice. But don't just watch the video. I've been making this point repeatedly, and I can't stress this more. Solving the problems, doing it yourself, is the essential part of mastering mathematics. So now the next question is to Jyoti. You know what is t squared? You know what is 2t squared?
200.
And you know what is 4t squared?
400.
So what is 2t squared plus 4t squared?
60 square.
6t squared. Very good. This time you didn't tell me the answer in 100. You told me in t squared, which shows that you are now becoming familiar with the language of t, the t language. T means 10, t squared means 100. What is t cubed, Jyoti? 10 into 10 into 10. Do it on your calculator.
30.
No, 10 into 10 into 10. T squared is 100.
1000.
1000. Okay. 3t is 30. But t cubed, 3t means t plus t plus t. That is 30. But t cubed is t multiplied by t multiplied by t, and that is 1000. So now we know, again I'll ask the question to Jyoti. What is t?
10.
T is 10. What is t squared?
100.
T squared is 100. What is t cubed?
1000.
1000. And if I ask you the next question, what is t to the power of 4, t fourth?
10,000.
10,000. Very good. Okay. So that is the language of t. Now let's continue. The next question is to Nandita. What is 2t squared plus 3t? Nandita, what is 2t squared plus 3t?
230.
230, right? This is 200 plus 30. So this is 230. Now, I will repeat a question which I had asked earlier. What is 2t multiplied by 3t, Gyanjyoti?
50. 5t.
We had done this earlier,
600.
600. So that is
60.
6t squared. Remember, the 6 comes from 2 into 3, right? You need a little bit of practice to be familiar with this. But once you're familiar with T language, then you can do a lot of algebra problems very easily. Okay, now let's do one last problem in T language before going to something new. Nandita, can you tell me without writing, just doing it in your mind, what is 3t multiplied by 3t?
900.
900. In T language?
90 square.
9t squared. Very good. And Gyanjyoti, again in your mind, you have to do it. What is 2t multiplied by 4t?
800.
800 in T language?
8t square.
8t squared. Right? So now we know how to do multiplication in T language. And let's go on to the next part. But before going on to the next part, can we just listen and take any questions from our viewers in Zoom and those who are on Facebook Live? You can type in your chat boxes. Shall we take some questions? Are there any questions?
Hello, participants. Are there any questions from your side? You can raise your hand so that we can unmute you. So should we move ahead? Or there are any questions? Yes. Parth.
Yeah, I was asking of t to the power 4 plus t to the power 3 plus 3t.
Just a minute, Parth. Can you repeat it?
Yeah, t to the power 4 plus t to the power 3 plus 3t.
What is e to the power of 4 plus e to the power of 3 plus t
Plus-
plus
Yes, sir.
3t? Okay, so this is the question that one of the participants, what is her name or his name? Parth. So instead of me asking Parth questions, Parth is asking me a question. Let me write down the question that he has asked me. I think this is the question. This is the question that Parth has asked. E to the power of 4 plus e to the power of 3 plus 3t. This is the question that Parth has asked. What is e to the power of 4 plus e to the power of 3 plus 3t? I can do it on a calculator, but I can also do it here. I can write the numbers. So t to the power of 4 is 10,000 plus 1,000 plus 30. So 10,000 plus 1,000 is 11,000. And 11,000 plus 30 is 11,030, which means 11,000, no hundreds, and 3 tens. 11,030 is the answer to the question that Parth has asked. Any other questions?
जर पायावर टाकू दे पाणी तू चाललीस
Shreyanshi, do you have a question?
Yes, ma'am.
Yeah. Go
My
ahead.
question is that 2 into t to the power 3 plus 4 into t to the power 4.
Can you repeat it?
2 into t to the power 3 plus 4 into t to the power 4.
Oh, okay. This is the question asked by Shreyashi. Okay. Now let me write this in numbers. So the first number is 2 times t to the power of 3, which is 2,000. The second number is 4 into t to the power of 4, which is 40,000. So 40,000 plus 2,000. Normally we write this on the largest first. But never mind, even if you don't write it first, you can add it. So 40,000 plus 2,000 is 42,000. So you can say it is 42,000. You can say it is 4 times t to the power of 4 plus 2 times t to the power of 3. You can also say that it is 42 times t to the power of 3, because it is 42,000. There are different ways of saying it. Okay. I think we have answered a few questions, and now we are ready to proceed further. In the last session, we used 2 languages for algebra. One was the T language, and the other was the language of rectangles. So let us now revise briefly the language of lines and rectangles. So let us look at the following graph. I'm going to show it up to you, and you have to tell me what. It's just, this is all recall, if you, from the last time. We did something like this. If I take 5 and 4, then this is 5 plus 4. This line here. 5 is a length of 5 steps, 4 is a length of 4 steps. So a length of 9 steps is 5 plus 4. That is addition. And 5 into 4 is a rectangle with 5 on one side and 4 on the other side. So 5 into 4, what is it?
20.
20. So where is the 20 here? The 20 is these little squares here. 1, 2, 3, 4. 4, 4, 4, 4, 4, 5 times. That is 20. That is the area of the rectangle. In area, we count squares. In length, we count steps. So 5 steps plus 4 steps is 9 steps. But 5 steps multiplied by 4 steps is 5 centimeters multiplied by 4 centimeters. That is 20 tiles. That is 20 square centimeters or 20 centimeters squared. Now, let us take a few more questions in this series. Remember, we did a question, what is 6 plus 3 and last time. This is the graph that we do last time. Recall, this is the graph that we do last time. 6 and 3. Six plus 3 and 6 into 3. So 6 plus 3 is a line, 6 into 3 is a rectangle. Remember, I'm just taking you through what we did last time. This was 5 plus 2. And recall that we could add horizontally. We could also add vertically. I could take steps horizontally or I could take steps vertically. So this is 5, 2 and 5 plus 2 shown vertically. Then the next problem we did was 6 times 9. But if you recall, we broke up 9 into 6 plus 3. So this was what we had done last time. 6 times 9. So this is 6 times 9, but 9 is 6 plus 3. We drew a vertical line. We saw that the big rectangle broke up into 2 smaller rectangles. This is all from last time. And then finally, we did 9 multiplied by 7 or 7 multiplied by 9, 7 times 9. And this is the rectangle that we made, if you recall. Take a look at it. So 9 shown at the top is 6 plus 3 and 7 is 5 plus 2. So I break up 9 into 2 parts and I break up 7 into 2 parts. And I get 7 into 9, which is a big rectangle. That is the sum of 4 rectangles. 1, 2, 3, 4. One rectangle is 5 times 6. The other rectangle is 5 times 3. Third one is 2 times 6. And the fourth times is 2 times 3. So I write the whole thing as a sum. Here I draw it as a figure. Now I write it as a sum. So 7 times 9 is 5 times 6 plus 5 times 3 plus 2 times 6 plus 2 times 3. Or 63 is 30 plus 15 plus 12 plus 6. I can also write one more expression showing this figure using brackets. I'm going to write that now and show it to you. Recall it was a revision from the last session. I'm going to write 7 as 5 plus 2. I'm going to write 9 as 6 plus 3. This is the last line which I have written. And for 7, I've used 5 plus 2, but I've kept that in a bracket. For 9, I've written 6 plus 3, that also in a bracket. So I get a bracket multiplied by a bracket. And there are 4 terms. This one, this one, this one, and this one. So multiplying brackets can be shown by making rectangles. I repeat that. Multiplying brackets can be shown by making rectangles and breaking up the big rectangle into smaller parts. So let's take this forward now with a few problems. Having done this revision, I'm sure you will find these problems quite easy. Let's take these problems forward. Are you ready? Draw a rectangle for 5 times 9 and break up 9 into 2 parts, 6 and 3. Have you done it? Jyoti, just show me what you have done. Okay, so you've drawn a rectangle, a 5 by 9 rectangle, and broken it up into 2 parts. Okay, now can you write in each part, the area of each part? Can you write that inside your rectangle? What are the 2 parts? One part is 30 and the other part is 15, right? So 45 is the sum of two parts. 45 is 30 plus 15. Very good. Now, the next problem, I'm going to give it to you now as an algebra problem, and you have to convert it into a problem of numbers when I give you the values of the algebraic. This is the problem. A into B plus C. This is the problem. And you just solve this problem. Gyan Jyoti just solved this problem. In the problem that Gyan Jyoti is just solved, Nandita, you have to answer the question. What was A?
5.
A was 5. What was B?
6 or 3.
6. What was C?
3.
3. Right? So now I'm going to give you different values for A, B, and C. You don't have to draw those on your graph paper. Turn the graph paper over. When you draw on graph paper, it takes time. I'm going to give you the problems. You have to draw the diagram and tell me the parts. Okay. What is, take A as 2, B as 3, and C as 4. So draw a rectangle. A is 2, B is 3, and C is 4. All the participants who are watching on YouTube and Facebook Live, you please also do this in your exercise books. What is A into B plus C, where A is 2, B is 3, and C is 4. And have you all drawn a figure like this? Where this is 2, this is 3, and this is 4. A into B plus C. This is the question. A into B plus C, where A is 2, B is 3, and C is 4. So the answer is 2 into 3 plus 4, 7, 14. 14 is 2 into 3, which is this part here, that is 6, plus 2 into 4, which is 8. So 14 is 6 plus 8. Okay. All right. Now the next question is the same A into B plus C, but now A is 10, B is 5, and C is 7. Same thing, A into B plus C, but A is 10, C is 5, B is 5, and C is 7. I've drawn it here. Okay. So Nandita, can you show me what you've drawn? And can you tell me in the mic, what is your answer? What are your parts?
70 plus 50.
70 plus 50, which is
120.
120. 7 plus 5 is 12. 12 into 10 is 120. And the two parts are 70, 7 into 10, and 50, 5 into 10. So now we know how to do A into B plus C for different values of A, B, and C. Now the next problem is draw a diagram for any values of A, B, and C. Keep A as A, B as B, C as C, and draw a diagram. And write the two parts. Now this is not 10, this is not 2, this is A. This is not 5, this is not 3, this is B, and this is C. So draw an abstract diagram for A, B, and C. So this is what we have here. This is what we have here. Have you drawn something like this? I hope all the participants are also drawing in your exercise books A, B, and C. And what we now have to do is to write the area of the two parts. So what is the area of this rectangle?
A into B.
A into B. And Gyanjyoti, what is the area of the second part?
A into C.
A into C. So please write that inside your rectangles. I will write it here. And now I will write the problem. So this big rectangle is A into B plus C. And that is two parts, A into B plus A into C. So please write that on your piece of paper. A into B plus C is A into B plus A into C. So when you have a problem like this, and I give you different values for A, B, and C, at that time, we can do it in many ways. I can do it on the calculator. I can do it by drawing a rectangle. And I should get the same answer. So now, please take your calculator, Gyanjyoti and Nandita, and I will give you a problem which you have to solve on the calculator. Are you ready, Gyanjyoti? The problem is A into B plus C again. A into B plus C, but here A is 7, B is 6, and C is 5. Do it on the calculator. A is 7, B is 6, and C is 5. A into B plus C. What answer do you get?
77.
77, right? That is because 6 plus 5 is 11, and 7 times 11 is 77. And what are the two parts?
7 into 6 plus 5 is equal to 77.
77. Now, if you draw a rectangle and you divide it into two parts, one part will be 7 into 6. The other part will be 7 into 5. 7 into 6 is 42. 7 into 5 is 35. 42 plus 35 is 77. So you can do it on the calculator. You can do it by drawing rectangles. And now, remember, we went further and we did last time. I'll show you the figure again, what we did last time, just to remind you. And then I'm going to give you a problem. Remember, we did 7 times 9, where 9 was broken up into 6 plus 2, and 7 was broken up into 5. 9 was 6 plus 3, and 7 was 5 plus 2. Let's take that figure, or let's draw it here again. This is the figure from last time. We'll just recall. This is something that we did last time. 7 into 9, that's 5 plus 2 into 6 plus 3, 5 plus 2 into 6 plus 3, and that is 4 parts. 5 into 6, 5 into 3, 2 into 6, and 2 into 3. Remember, this was something that we did last time. Now, I'm going to ask you to draw a similar rectangle for A plus B multiplied by C plus D. So please draw a rectangle for A plus B multiplied by C plus D. Do this as a rectangle. So this is the figure I think that you may have drawn. This is A plus B multiplied by C plus D. And we get the four parts. One part is A times C, the other part is B times C, the third part is A times D, and the fourth part is B into D. So now, can you write this now using brackets? Let me show you what we had written for 7 into 9. Just recall what we had written for 7 into 9. 7 into 9 is 5 plus 2 into 6 plus 3. So that's 5 into 6, 5 into 3, 2 into 6, 2 into 3. We wrote it in different ways. 7 into 9 is the sum of 4 parts. 63 is the sum of 4 parts. But we also wrote it using brackets. That is 5 plus 2 multiplied by 6 plus 3. And these are the 4 parts. 5 plus 2 here, 6 plus 3 here. So now if instead of 5, 2, 6, and 3, I have A, B, C, and D. Right? So how will I write it? Right? Please write down using brackets. Instead of 5, 2, 6, and 3, I have A, B, C, and D. Please write it. You have written it? Please let us see what you have written. Very good. A into B, brackets, A plus B, close brackets, into C plus D. And that is 4 parts. A into B, A into D, B into C, and B into D. These are the 4 parts. So now we know how to write the algebraic multiplication using rectangles and breaking up into rectangles. And we know how to write it without making rectangles, just by using brackets. So now, are you ready for a problem where you have to do both? You have to draw the rectangle, and you also have to write it using brackets. Now the problem is the following. The problem is, I'm going to write it here. A plus B into, now instead of breaking one side into 2 parts, I'm breaking it into 3 parts. So it is A plus B into C plus D plus E. This is the problem. A plus B into C plus D plus E. So let us draw the rectangles. Have you drawn a figure? Jyoti, have you drawn your figure? Let me see what you have drawn. I hope all our participants and friends all over the world are also drawing figures in your exercise books. A plus B into C plus D plus E. You draw in your exercise books, and let's see what Jyoti is doing here and Nandita is doing here. Nandita, can you hand me what Jyoti has done? Just hand it over to me. Okay, this is what Jyoti has done. Her rectangle breaks up into 6 parts, and each part is A into C, A into D, A into E, B into C, B into D, and B into E. That's correct. So now we know how to multiply brackets which have 2 terms, 3 terms. So now we have entered into the realm of algebra. We are doing algebraic multiplications, additions. That is mainly what algebra is all about. And now let's take this a little forward. And now let me ask you a question. Instead of A, B, and C, I'm going to use a different symbol. I'm going to use now X and Y. Nothing complicated, the same thing, except that I'm using now X instead of A. So the first problem is, I'm going to show you a figure. You have to tell me, what is this? Nandita?
X square,
Why?
because it's X into X.
It is X into X, so this is X squared. Right, very good. Now the second problem is, we've taken and now I'm asking you, what is this? This is X and this is X. So what is this?
X plus X.
X plus X, which is
2X.
2X. So this is 2X and this is X squared. Okay, this is just revision, nothing new. All right, now tell me, this is Y and this is X and this is X. So what is this?
X plus X
This is Y, X plus X
into Y.
into Y. But what is X plus X?
2.
You just told me
2X.
2X. So this is 2X into Y.
Y.
And that has got how many parts? There's this rectangle here. This rectangle here is
X into Y.
X into Y. And this rectangle here is?
X into Y.
So X into Y plus X into Y is? We call that 2XY.
2XY.
Okay. So 2X into Y is XY plus XY, which is 2XY. Okay. Now, let's go further. Okay, I'm going to show it to you again. This is x into x, which is x squared. This here is x plus x, which is 2x. 2x is just another name for x plus x. Then this rectangle here is x plus x into y. So it is 2x into y. And I can break that up into two rectangles. I'll just draw the rectangle separately. This rectangle is xy plus xy. So 2x into y is xy plus xy, which is 2xy. So now, there is only one more thing that we have to understand. What is 2 into 3?
6.
What is 3 into 2?
6.
6. What is 10 into 5?
10 into 5. 50.
50. What is 5 into 10?
50.
So we know that x into y is y into x, right? They are both equal. Just keep that in mind. A into B is the same as
B.
B into A. Okay. So now we know that A plus B into C plus D is, remember you have just done it? 4 parts. What are the 4 parts?
A into C. A into D. B into C and B into D.
B into D. Okay. So now I want you to solve the problem. You know how to do A into B times C, A plus B into C plus B. Now I'm going to give you a problem which is simpler. You have to solve what is A plus B into A plus B. Draw the diagram and get the parts. So did you get the 4 parts? What are the 4 parts?
A into A plus A into B plus B into A plus B into B.
Plus B into B. But we know that A into B is equal to B into A. We know that A into A, what is the name for that? What is x into x?
2x. X squared.
X squared. X into x is called x squared. So A into A is called
A squared.
A squared. B into B is called
B squared.
B squared. So can you write that now using a squared, b squared. Can you write that? A plus b into a plus b is what do you get? A plus b into a plus b is tell me the four terms now. What are the four terms that you got?
A square
Yes.
plus b square
Plus
b square
b squared
plus 2ab square.
ab squared. It was ab plus ab. That is, what is ab plus ab?
2a plus b.
ab plus ab. Remember we got xy plus xy?
2ab.
2ab, right? So now say the whole thing again.
A square plus b square plus 2ab.
Plus 2ab. That is the well-known formula for a plus b into a plus b. A plus b into a plus b, we can also call it a plus b the whole squared. So a plus b the whole squared is a squared plus b squared plus 2ab. Okay, all right. Now I'm going to give you some problems that we have done earlier, but now I'm going to give it to you in T language. And we're going to use rectangles and T language together. Okay? So the problem that you have to do is T plus 2 into T plus 3. Take a fresh sheet of paper and do T plus 2 in brackets multiplied by T plus 3. What do you get? T plus 2 multiplied by T plus 3. What did you get, Nandita? You're doing it. Okay. Please do this in your exercise books. T plus 2 into T plus 3. Have you done it, Jyoti? What did you get?
T into t plus t into 3 plus 2 into 3 plus 2 into 3.
So 3 into t is 3t. 2 into t is 2t. So what is 3 into t plus 2 into t?
5t.
5t. So right, and what is t into t?
T square.
T squared. So write that now as so what did you get, Gyan Jyoti? Say that in the mic.
T square plus 5t plus 2 into 3.
What is 2 into 3?
6.
6. So t squared plus 5t plus 6. But you know what is t squared? What is t squared?
100.
You know what is t? What is t?
10.
So what is 5t?
50.
Okay, so now put the values and work it out. Put the values for t and work it out. What did you get? Janjoti?
100 plus 50 plus 6 is equal to 156.
156. Okay. Now you have done this by drawing rectangles and finding the parts and adding the parts. Do this problem on the calculator. T plus 2 into t plus 3. So what is t plus 2?
20.
T plus 2.
10 plus 2.
Which is?
20. 20.
10 plus 2.
12.
12, not 10 into 2. Okay. Don't confuse multiplication and addition. So this is t plus 2 is
12.
12. T plus 3 is
13.
So do 12 into 13. What answer do you get?
156.
Which is, how will you write 156 expanded form?
T square.
Say that in the mic.
T square plus 5t plus 6.
So doing on the calculator, you get the same thing. Doing it this way, you get the same thing. All right. Now we have done a plus b into, we have done a plus b into c plus b plus e. Right? Remember, we have done a plus b into c plus d plus e. Now I'm going to give you values of a and b, c, d, and e. Put a as t and b as 3. So a plus b is
3t. 100 plus 3.
a is
T.
t. T is what?
10.
10, not 100. So a plus b is
13.
13, right? So write a plus b as t plus 3, write it. Write in brackets, t plus 3. And now c is t squared. D is 2t. And E is again 3. So you have A plus B into C plus D plus E. You have A plus B into C plus D plus E. Where A is T, B is 3, C is T squared, D is 2T, and E is 3. So now you wrote for A plus B, C, D, and E. So write the terms now. Done it? This was the problem. T plus 3 into t squared plus 2t plus 3. Numbers, it is 13 into 123. Remember we did this last time? Okay. Now you have to tell me the terms. What are the terms? Nandita, can you tell me? Did you get the terms?
1000 plus 200 plus 30 plus 300 plus 60 plus 9.
Let's say that a little louder in the mic.
1000 plus 200 plus 30 plus 300 plus 60 plus 9.
Plus 9. Can you say that in T language?
T cube plus 2t square plus 3t plus 3t square plus 6t plus 9.
9. So when you put all the t squares together, what do you get? Put the t squared together, put the t's together, and tell me how many t squares do you get? How many t's do you get? This is the problem. Nandita, can you tell me what you get?
T cube plus 5t square plus 9t plus 9.
T cubed plus 5t squared plus 9t plus 9. So what is that number?
1599.
1599. 1590 plus 9, which is 1599. Okay. Do that on the calculator and see what you get. On the calculator, what numbers will you multiply? What do you get, Janjoti?
1599.
You get the same answer on the calculator, right? So using T language and rectangles, we can do 2-digit, 3-digit, 4-digit multiplications. And these multiplications are very easy because multiplication in T language is very easy. We know that T times T is T squared, which is 100. We know that T times T squared, that is 10 times 100, is T cubed, which is 1000. We know that T squared times T squared, that is 100 times 100, 4 zeros, that is 10,000. That is 10 to the power of 4. We know that multiplying by 10 is very easy because all we have to do is count the number of zeros. Similarly, multiplying in T is very easy because all that we have to do is to look at the powers of T, whether it is T or T squared or T cubed or T to the power of 4 or T to the power of 5. It's just counting the number of zeros. And when we use t, we are using arithmetic, which is something that we know, to understand algebra, which is something abstract. We are going from the concrete to the abstract. Rectangles tell us how to combine multiplication and addition. And in order to confirm that you have understood what we have done, I'm going to give you a tough problem. Are you ready for a tough problem? Nandita, are you ready? Kyanjyoti, are you ready? Okay, the problem is, I'm going to write it here, and you have to tell me what is the answer after combining all the equal terms. This is the problem. What is A plus B plus C into A plus B plus C? We did what is A plus B into C plus D plus E. Now I'm saying A plus B plus C into D plus E plus F. But here D, E, and F are just A, B, and C. So it is A plus B plus C into A plus B plus C. So draw the figure and tell me what are the parts. All the participants who are joining from Facebook Live and YouTube Live, please do the exercise in your books, in your exercise books, and let's see if we have understood what we have been doing today. I'm going to draw the figure here. Yeah, so while you are doing it there, let me show you what I have done, and you can compare what you have done with what I have done and see whether you have the same. I have drawn this figure, A plus B plus C into A plus B plus C. So I have, my length is divided into 3 parts. My height is divided into 3 parts. When I multiply, I get 9 parts. The 9 parts are A squared, AD, AC, then BA, B squared, BC, CA, CB, and C squared. If I combine all of them, so I get A squared, B squared, C squared, A squared plus B squared plus C squared, and AB and BA are the same. AC and CA are the same. And BC and CB are the same. So I leave that as a homework problem for you to put all this together. And I want to now conclude because we have reached the end of our session. The bell has gone. So, ghanti baj gayi hai. So let me quickly summarize what we have done. We have done algebraic multiplication and addition in T language, in the language of rectangles. And I want you to note something which I mentioned the last time also, especially the teachers who are watching this. Please note that in this entire set of problems that we have solved the last time, this time, we have only used positive integers. 1, 2, 3. We have not used negative integers. We have not used negative integers. We have not used negative integers because we have not done negative numbers so far. So hopefully the next time when we meet, we will do negative numbers. After doing negative numbers, we will again come back to these identities where there are negative numbers involved. Today we derived one main identity, which was a plus b the whole squared. We saw that it was equal to a squared plus 2ab plus b squared. Now that we know how to multiply using rectangles, all the algebraic identities will just follow as water falls down a waterfall. You know how to multiply rectangles, all the identities emerge from that. You don't need to memorize identities. You can immediately derive them because you know how to derive identities. So hopefully next time we will be discussing negative numbers. Then we will see how to combine algebraic identities with negative numbers. Then when we do fractions, we will also see how algebra combines with fractions and decimals. So we have concluded the first part of our friendship with formula. 4 sessions with geometry, 4 sessions friendship with formula. Next time we go to a new section, which is numbers, where we start discussing negative numbers, fractions and decimals, maybe 3 or 4 sessions in that direction. We will come back to geometry and algebra in future sessions. Thank you. Goodbye.